Okay, so we're moving on to graphing inequalities. Today is our topic. In your learning target, you're going to be able to graph and write inequalities. So you need to know what inequality means, and it represents a set of possible solutions. If you break it up, we have n equal, meaning the value of the variable doesn't equal just one thing. X is going to equal an infinite amount of things. Like x could, if I say x is bigger than 7, then you could say, well, then x is 8, 8.2, 8.09, 1,020,111. I mean, it could be anything, all the way, and it could also be infinity, okay, which is a non-existent number. So x could be anything, it's not just one thing. That's the difference between inequalities and an equation. An equation, it means that x equals one thing. Inequality means x equals a bunch of things, an infinite amount of things, actually. A solution of an inequality means it makes the inequality true. Okay, so the first thing we're going to do here is graph solutions of inequalities. The first thing you want to do is make a circle on a number line. You're going to have to create the number line. Don't be dramatic, it's not that hard. You make a nice line. I usually have 0 in there and the numbers that I'm talking about. Takes a little bit of time, but you can do it. And then you need to determine if you're going to color it in or not. Does anybody know how you know if you color it in or not? Have you been exposed to this?
Yeah.
If there is a line under it, it means color it in. So this would be bigger than or equal. That's how you say that. The line means or equal. And if it means it can equal it, you color it in. If it's just bigger than, you don't color. You only color if there's a line under it. And then you need to determine direction. Bigger than goes to the right, less than goes to the left. It's a number line. So if it's bigger than, clearly bigger goes to the right. If it's less than, clearly less than on a number line is to the left. Okay, next page. I can change it. We're going to do a couple examples. Here I have the number lines given for you. So make a circle, determine if you color it in, and then put your arrow. Circle, color it in or not, an arrow, okay? So here I have y is greater than or equal to -3. So I make a circle at -3. Do I color it in? Yes, because there's a line under here, so that means color it in. And I'm bigger than. Does bigger than go to the right or the left?
Right.
Bigger than goes to the right, and that's how I make my inequality. Now please know that the arrow means it goes all the way to infinity. Me stopping at 5 doesn't mean that the line stops at 5. It means that I'm just representing with this arrow that it goes all the way to infinity. If you just have this in your homework, I will count it wrong. Because that's, to me, telling them, hey, it all of a sudden stops at like 2.5. You have, in order to represent that it goes on for infinity, you have to have the arrow head. Yes?
If we draw it all the way to the arrow on the end of the line,
Nope.
we still have to draw it.
Yep, because that tells me it stops at 11. Oh, come on. It's just a little arrowhead. It's fine. Okay, x is less than -3. So where do I put my circle? tell me. -3. We didn't do very good at telling me. Do I color it in? Yes or no?
No.
What way do I go? Left. Smaller. Smaller numbers go to the left. Include your arrow. Okay? Z is less than or equal to -6. Where do I put my circle?
Color number
-6. Do I color it in?
Yep.
Yes, because there's a line under it. And then which way do I go?
Left.
Left. Left because I say less than. Some of us, in all honesty, some of us might forget that this means greater and this means less. Okay, if the open mouth is facing to the left, it's bigger than. If the point is facing to the left, it's less than.
I have a trick.
I know what your trick is going to be. I bet you, do you want to see? I'm going to be psychic here. Do you want to see? Do you think this? Is that what you're thinking your trick is? Yeah. It works, but only, it doesn't work all the time. Okay? So Eli's noticing, hey, the arrow goes the way the inequality symbol goes. Well, it sure has worked that way so far, hasn't it? Notice I got that going on. It has, but it's not always the case. That's the only thing. And then when it doesn't work is coming up in a couple pages. It only works if the variable's on the left-hand side. If the variable's on the right-hand side, that strategy does not work.
Then it's the opposite.
Yeah, that's a good way to think about it. So when it's on the opposite side, you go the opposite direction. I like that. That's a good strategy.
I didn't think it was a strategy, I just said it.
Oh. Okay, so next learning target, writing inequalities from graphs. Remember, you can graph and write. That's our learning target. So you write the number the circle is on. And then you determine direction of the inequality. I guess that's all. I don't know why I have that space there. I'll probably remember in a couple of minutes, but that's all you need to do. Write the number the circle is on with the variable and then determine direction. Okay? So notice here I have the circle's on 0. So I write x. Now am I bigger than or less than 0? Am I going to the right or to the left?
Bigger.
I'm bigger, right? I'm getting bigger.
Or equal to.
So you say bigger than or equal to 0. Okay, next one. I always start with my variable, x. And I'm getting smaller now because I'm going to the left. So I say is smaller than or equal, because it's colored in, smaller than or equal to -7. Yep. Yeah. I'm not really sure what.
It's like, you know how it's like you show the inequality sign and then you have equal, you have equals, like what equal sign and then the inequality sign.
I think so. I'm feeling a little less because I can't hear that well. So let me just continue moving forward and we'll talk about that in a minute, okay? Okay, the next one, why do I have everyone equal to? That's not going to happen where they're all equal to. So here I put my x. I'm going to the right, which means I'm getting bigger. So I say is greater than or equal, because it's colored in, and then the number 5. So you're going to have to create graph inequalities and create an inequality from your assignment. And here is when that one strategy gets a little off.
And then you
task.
die.
So when the variable's on the right, notice some kids think the arrow is going to go this way because they've developed that strategy that thinking that the arrow is going to go the direction the inequality symbol is. That only works when the variable's on the left-hand side. So here, this is what I say. 5 is greater than or equal to x. So if 5 is bigger than x, what is x? Smaller. So if 5 is bigger than or equal to x, then x has to be smaller than 5. So I put a colored in circle at 5 and I go to the left. Okay? Now a strategy that Zach just came up with, if you see the variables on the opposite side, put the arrow in the opposite direction. That would work too. That's pretty cool. I like to think logically about it. So this next one, this says -3 is smaller than x. So what is x? Bigger. If -3 is smaller than x, then x needs to be bigger than -3. So I need to make a colored in circle at -3 and make x bigger. Again, opposite side, opposite direction. Oh, this is funny. This you just have to add it up quick. -7 plus 3, what's that?
-4.
Yeah, so I have -4 is bigger than x. So if -4 is bigger than x, what is x? Smaller. If -4 is bigger, then x is smaller. So I make a circle at -4. I don't color it in because there's not a line under it. And I make x smaller. Okay, so that's one of the trickiest parts regarding graphing inequalities. There's probably going to be about 40% or so of us that mess up the inequality symbol there, so be careful. Real life situations, inequalities is all around us. For example, I can have at most 36 students in this classroom. So, I mean, I can't just have one specific number. I can't say, hey, I can have 32 kids. I can have anywhere from 36 to 35 to 34 to 33, all around. Or if you say, if you go shopping and you have $1,000 to spend, wouldn't that be fun? If you had $1,000 to spend, you would say what I spend has to be less than or equal to $1,000. Inequality is all around us in real life situations. I do want you to write some words that you need to know. You need to know the word at most and at least. I see those come a lot. So let's define what at most means. If I say I can have at most 36 kids in this classroom, does that mean I can have more than 36 or less than 36? Less than. Can I have 36 kids in this classroom? So it's actually less than or equal to. Or if you're having a party and your parents say you can't invite all your friends, they're like, you can invite at most 8 people. Well, I mean, sometimes it stinks deciding who you're going to invite, but you can invite 8 people or less than 8 people. At least, you have to be at least 48 inches tall to ride a roller coaster. Does that mean you have to be bigger than 48 inches or smaller than? Bigger, right? So you want to say bigger than. Can you equal 48 inches? Yeah, greater than or equal. So those are the 2 real life applications with it. Okay, so let's read this first example. You pay for 3 CDs with $40 and you receive money back. Write an inequality that models this situation where C is the cost of the CDs. Now I don't know how much the CDs were, but I know that I gave the cashier $40 and I got money back. So my cost, was it bigger than or less than 40? It was less than 40. Did I equal $40? Can I equal it? No, because I got money back. So it's just C is less than 40.